Also, like I said earlier, these two sample means are the most accurate because they equal the population mean of 57, and this sample mean of 55 and this sample mean of 59 are the least accurate because they're the furthest away from the population mean of 57. So as a researcher, I would really like to get one of these two samples, and I really wouldn't like to get this sample or this sample. But remember, the sample that I get depends on chance. So as a researcher, I have to hope that I get an accurate sample. Let's now look at one other example of how the mean of the population equals the mean of the sampling distribution. We already know that the mean of these four people in the population is 57. If you add their four heights and divide the total by 4, it comes out to 57. And what we're going to look at right now is how the mean of these four sample means also equals 57. If we add the four sample means in this sampling distribution and divide the total by 4, we get 57. So the point that I'm making here is that the mean of the sampling distribution equals the mean of the population no matter what sample size you're dealing with. It doesn't matter if the sample size is 2 or 3 or any other sample size. So here's another visual of how the mean of the population equals the mean of the sampling distribution. This is just the same figure we looked at earlier. It's the heights of the 4 people in the population, and the population mean of 57 is at the center. Over here, these 4 sample means are the means of all of the possible samples of 3 people that could be selected. And at the center, we have the mean of the sampling distribution, which is the same thing as the population mean. And we can see that down here, these sample means underestimate the population mean of 57, and these sample means overestimate the population mean of 57. And one point that you've probably already noticed is that these 4 sample means in this sampling distribution are packed in closer to the population mean compared to the sample means in the other sampling distribution with a sample size of only 2. Because when we were looking at the other sampling distribution with a sample size of 2, we had a sample mean down at 55 and a sample mean all the way up at 59. But now all of our sample means are between 56 and 58. All of our sample means are pretty close to the population mean of 57. So like I said, when the sample size goes up, the sample means move in closer to the population mean. That's just because bigger samples are more accurate and more dependable. So here we have a visual that shows us that the 4 individual people in the population have the most dispersion. Their individual heights have the most dispersion. The means of the possible samples of 2 people have less dispersion. They're closer together than the individuals are. And the means of the possible samples of 3 people have even less dispersion. So as you go from, when you go from each value being 1 person to each value being 2 people to each value being 3 people, the values move in closer and closer to the center. They have less and less dispersion, like we see in this diagram. So the main point behind this diagram is that larger samples are more accurate than smaller samples. If you want to estimate the mean of a population, you're better off with a larger sample than with a smaller sample. Because if you use a larger sample, your sample mean is likely to fall closer to the population mean that you're estimating. So all 3 of these distributions have the same mean. They all have a mean of 57, which we can see here. we can see that all three of these are pretty much centered at 57, but they don't all have the same dispersion. Like I said, the left one has the most dispersion, the middle one has less, and the right one has the least. So since we're talking about the dispersion of a sampling distribution, that actually leads me into our next concept, which is called the standard error. The standard deviation of a sampling distribution is called the standard error of the sampling distribution. So I told you that